reactant is water or a product is carbon dioxide or something like that. And you have to know, how do I want to say this, that where they go. One's on the left, one's on the right. All right.
Yeah.
Any questions on that before we proceed?
No, I have that.
Good. Okay, so the next question here talks about what type of reaction there. Then they're giving you 1, 2, 3, 4 different types.
Mhm.
Okay, so the best way to do this is for me to show you like one of them, like say a synthesis, which is what letter A is, and then talk to you like about, well, why is it letter A, or why is letter A a synthesis? So this is definitely a synthesis. And you can see on the left there that 2 reactants, again, that's why they want you to know that, become one product. 2 reactants become one product. So when you look down this list, it's like, do you see any other where there's 2 things on the left side? You see how there's Na and O2, 2 things on the left side, but only one on the right. Do you see anything else in that list there?
That's synthesis? No.
I agree. I agree. So identification is really important. All right. Now the other direction is decomposition. Okay. So decomposition is where you go from 1 to 2. So you can see letter B is clearly decomposition. Maybe you saw this in class, but you have 1 reactant and that goes to 2 products. So it's basically the flip or the reverse of the other.
Mhm.
Is that something you've heard before?
Yeah, I have number 3, like the whole balancing the equation thing. Pretty sure I have that down because it would be C is single replacement, D is double replacement. I'm not entirely sure what E is, and then F is double replacement.
Okay, so the question that I have for you, or the thought would be like, do you understand the why they are what they are? Like it's easy to go out and type these into the internet and know that this is synthesis, this is decomposition, but is it clear why they are the way they are?
I think so, yeah, because so I know that I don't think combustion is in that one, which would mean that the ending is CO2 and H2O.
Right.
So that's why I had E as combustion, even
It,
though
it is. You're right, and E is combustion. And
oh,
I was gonna ask you why that isn't on your list, because
it is.
whenever water is formed, it is combustion.
Yeah, and then with so C like single replacement, there is one new like pair, or not pair, but one new like element being introduced, and then there's 2 being switched out.
Right. So which of the list is single replacement? Which one did you say?
For single replacement, it was C.
Yes. So I don't know if you saw this in class, because there's a few different ways that they can write, but they write it kind of like this, like A plus BC produces AC plus B.
Yeah.
And the idea is that the one that was together gets split apart, and one of those combines with the old one.
Yeah.
Okay. All right. So like you've already done some of this is what I'm hearing. Now it did say to balance, which we have not done. I don't think the first few are very challenging to balance, but maybe like letter E we could balance. Have you done that?
I haven't done that yet, no.
I have not done that. Okay, so let's take a look at that. Tell me what you remember from class about balancing equations.
Like, well, it's the like you already have, so you put in the charge. So like for E, it's C is 3, H is 8, and then O is 2. And we know on the other side of it, like after the arrow, that O is 2. C in this case would end up just being 1, I believe, because that's the charge. And then H would be 2, and then O in that case is 2 as well, because just O in general is 2. So then I have to like balance it and put numbers in front of each element to make each side the charges the same.
Got it. Got it. Okay, so just to clarify a couple of things, these are not the charges. These are just telling you the number of the element that you have. But they're definitely not the charge. So just want to clarify that for you. Okay.
So it wouldn't, is just more about like, oh, there's one C in the
There's
first
three
side.
there's three C's.
What I mean in the second side.
Yes, there's one C in this on the product side. Let's
Yeah.
yeah, let's use those words there. Now the charges of these, which we can get to, like they are typically neutral when they're like this, but like they're not emphasizing that right here, so you don't have to worry about that.
Yeah.
The reason I was asking is because there's some techniques to balancing that are important here. Like, do you see that there's a C in only one position on both
Yeah.
sides of the equation? So you would either start with C or H, balancing those for the same reason, that they only appear in one position. And you would deal with O last because it appears in two places on the right, on the product side.
Right.
So if you're like, all right, I'm going to balance C first, you would put a 3 here because there are 3 C's on the left. And now this number in front multiplies how many there are here, which is 1. So there's 3 C's. That's
Mhm.
balanced. Okay. The H's, there's 8 on the left, only 2 on the right. So if you put a 4 in front, now
And
the H's are balanced, but you have 3 times 2, 6 O's, 4 O's there, that's 10 O's. And what some teachers do is or some students do is they make a table. They'll do CH and O, CH and O. I'm all for that if you like it. But the result is you've got 10 O's on the right, which means you have to manipulate this coefficient here. What would that make the coefficient in front of O2 be?
5.
5. You got it. So it's what's called an iterative process. You have to do it, over and over, and kind of like connecting to Zoom today. You just keep trying it until you get it to work.
Yeah.
And that's what this is. There's not really like a formula or recipe where you just follow that and it works each time.
Yeah.
All right. And these can be very frustrating, especially in a stressful test situation. So let's look at one more here. Let's look at that last one, F. By the way, what type of reaction is this?
Double replacement.
It is double replacement. Yes. Okay. So like one of the things I mentioned here that like Na and Na, they appear in one place. Cl and Cl appear in one place, but they're already balanced. You've got one Na, one Cl. So that's good. So it really just comes down to this. And there's two H's. How many are on the left?
There's 2 H's on the left as well.
Good. And how many O's between?
There's 2 O's on the there's 2 O's on the reactant side technically, right? Or because
We're talking about this one, this side here, right?
yeah. So that would just be one.
I see one O. Where are you seeing the other O?
Well, I just thought that because at least like the way we have, or what I've understood is that there's always going to be like when there's a 1 O, that means that there's like 2 because of the charge. But maybe I just didn't understand that.
Yeah, it has nothing to do with charge. So okay, so just a little bit on charge. On your periodic table, what is Na's charge generally?
NA's charge is normally
And if you don't have a periodic table, let me send you a link to one.
it's 1. It's 1.
It's 1. Yeah, it's +1. Now OH is known to be -1.
Yeah.
So this is neutral. This is neutral here. There's a word for that. I don't remember exactly what it is, but this is neutral. Let's look at H. What is H's charge typically?
H's charge is also 1.
And Cl is minus.
Mm-hmm.
Did you see how that is this is neutral?
Yeah.
Same thing with Na and Cl. Na is plus, Cl is minus. The oddity here is a little bit is H2O, but it still fits. O is 2 minus or -2. H is normally +1, but you have 2 of them, which makes it +2. 2.
Right.
Okay, so the net charge here on all of them is 0. So just to be clear here, the subscripts mean that there's 2 of them. It has nothing to do with its charge.
Okay.
Okay, now let me just pull one up here. Let me just make one up here. Let's say I tell you it's SO42. How many S's and how many O's do you have? If you know, I don't want to, if you're
Um,
not sure, I don't want you to guess, but
uh, wouldn't the, okay, well, the two, wouldn't that like be going into it?
that's
So
right.
there would be 8 O's and 2 S's.
Yes, very good. Very good. Okay. Um, yes. Okay. Let me try one more balancing equation.
Mm-hmm.
One that's maybe a little more difficult than these, just to see if we've got it.
Yeah.
Okay, so here's one. Just check here. Yeah. All right, so take a look at this here. Tell me which element you would start with and to balance and why.
Um, wait, to which one are you saying?
I'm asking you, I'm saying which one would you balance? Like which one would you start with? And the options are A, L, O, H, or BR. Which one would you start with and why?
Yeah, because they're both the like first ones.
So, you said, I'm sorry, did you say AL?
Yeah,
Yes, and that would be fine. There's one AL and one AL here. Okay,
right.
good. And
Mhm.
now what that means is that more specifically is that these numbers match, like whatever is in the left is going to match the one on the right. So if you put a 1 there, obviously it's a 1 there. Okay.
Right.
So what I recommend then is going to the next one that only appears in one position, the BR. Okay. So
Okay.
how many BRs are there here?
There is 3 there, and on the other side there is 1.
Well, for now, right? You can quickly make that into
3, yeah.
3, and that's good because now we've checked the AL and the BR. Now I would go probably to H, since H only appears here. Well, I'm sorry, appears 2 places in here. So we could go to O because O only appears here.
Yeah.
How many O's do you have on the left?
There's 3.
3 O's. Okay, and on the right,
1. So I need
one's
3 in front of
3
there.
there. Okay, so now everything except for O has been I'm sorry, everything except for H has been balanced. So on the left, you have 3 H's, sorry, and
Mhm.
3 H's, that's 6. How many do you have on the right?
Um, 6.
6. So it is now balanced. Okay, so let me have you try one here. I do have another thing to do in the next half hour. So this will be our last problem for today. And I'll grab your mom real quick in a moment here, but let me have you try one here to see, try to work this one out on your own and let me know if you have any questions
Okay,
along the way.
I do think I have that. There is one that I specifically like need help with, like if that's okay. There's like for 4, and it says write a balanced equation for the following reaction and identify the type. I have A and B, but I'm confused about C. So like zinc carbonate reacts with lithium to yield dot dot dot. Like I don't get the how I'm supposed to turn it into something.
Okay, so they're trying to get you to know what this becomes, and this is one of the limitations of my ability to help you is I don't know whether carbonate is CO3 or CO2. I'm going right out to Google to learn this because
It's CO3. I have like a sheet, a
right.
common ion sheet,
Okay,
and it's
so
CO.
Got it. So the point here is like I'm just going to go and look for this. So it's ZnCO3 reacts with lithium. So is it Li or is it Li2
It's Li.
to produce? And this is where I don't know. And this is where I go to there's some equation tools out there where you can get the answers. So let me see equation. Let me see if I can find one that I used with a student fairly recently. Yeah. So you're pretty sure it's ZnCO3 plus Li.
Yes.
Okay. That didn't work. That was not. So this is probably a single replacement where Li goes with CO3 and then zinc comes off of the side here.
Okay, and so how do you like know that?
Well, yeah. So the answer to that question is based on like a little bit of your periodic table. Like, do you see that Li is charge +1,
Yeah.
and zinc is, sorry, Li is +1. What is zinc? Zinc is
Zinc is,
unclear. It's in the +3.
I think, yeah,
And that's where I don't know if is carbonate always -3 or is it
it's -2.
yeah. So that's where there's a problem here. And I don't know if it's like it's two of these and then two of these, because then you get the charges to balance out. Oh, you said -3 of those. That doesn't quite seem right. So that's again where I'm a little bit at a loss for how to help you on
Okay.
this. Let me really quickly see if I can find this one more time. Some a better answer for you.
Okay.
Yeah, see, I'm seeing that it is just ZnCO3 plus Li produces Li2CO3 plus zinc is what I'm seeing. So let me remove some of this because this is not right. Li. All right, and then there's a 2 here. So what I'm using here is an equation solver
Hmm.
to help with this, which I know you don't have, but it helps with homework. Let me see if I can drop that in the chat. Okay, so if your mom's around, we can do a quick wrap up on this and talk about how I can best help you guys. But
Um,
if she's available, if you want to grab her, if not,